Okay, so as I mentioned in the formula sheets, the big things we're going to be doing are adding and subtracting and fractions and multiplying and dividing and whichever. We already did a whole bunch of factoring in the trig introductory chapter 2 chapters ago. So we're not going to redo all that factoring. We're going to assume that you know it. So make sure you know all that, but we haven't really introduced adding and subtracting fractions, or we're working with fractions really. So let's start. 1 over cos x, or secant x, minus sine x over cosine x is equal to. Now, 9 times out of 10, I'm going to go down the page. Sometimes I'm just going to go off to the right really quickly and circle the answer just so I don't have to waste so much space on the page. One more time. Big red. 99% of the time go down the page. 1% of the time I'm going to answer the question off to the right. So I have a lowest common denominator of cosine x, and I just put the tops together. 1 minus sine x. Circle my answer. Kind of looks like the Pythagorean identity, but it's not. So I'm going to erase these lines, and from now on we're going to go down the page. So let's start with something in the next section. 1 over sine x. Notice I always use the graph paper lines. Perfect, up and down. The line is always on the line. There's the top and the bottom. Anybody who doesn't do that, fraction skills are horrific. So I suggest full-size fractions, always top and bottom, or with a complex fraction, with a top of a top and a top of a bottom and a bottom of a top and a bottom of a bottom. I digress. I continue. Minus sine x. Well, again, another reason I do full-size fractions, sometimes even bring out red pen like I think you should, but in the notes most of it's black for all sorts of reasons. But on the left I have a lowest common denominator of sine because sine x is over 1. So I need to multiply the top and bottom by sine x. So I do it right in the question, and a lot of the times I use a different color so I can still see the initial question when I want to go back and look at it. Now, why did I do this? Well, I did it so I can have 1 over sine x minus, now I'm going to multiply fractions, sine x times sine x, like we spoke about in the last, whichever, is sine squared x, and over the lowest common denominator that we were shooting for. Now, I have a lowest common denominator of sine x, and I simply say 1 minus sine squared x on the top. And I want to show you a really fun method that I learned in university. Extend the fraction underneath the sign to the other fraction and cross off one of your denominators, and it actually makes sense. I'm going to circle it in red and erase it in a second. Extend your denominator under the sign and cross off one of your denominators if you found the same denominator. Now I'm going to erase that. So that was fun. So now I have 1 minus sine squared x on the top. And I've already proven it in formulas, but I'm going to do it one more time. I'm going to write the Pythagorean identity on the page. Sine squared x plus cos squared x equals 1. I'm going to shrink that and I'm going to move it to the left a tad. So remember, we're not going to be adding and subtracting to both sides of the equation anymore. We have to be able to visualize things being on one side positive, moving them to the other side. So I'm looking for big red off to the left, 1 minus sine squared x. Now, how could I manipulate this equation to say 1 minus sine squared x? Well, if I subtracted sine squared from both sides, I would be left with cos squared x equals 1 minus sine squared x. Exactly what we were looking for off to the left. So I can replace the numerator, the top, that says 1 minus sine squared x, with what it's equal to that we proved off to the right with one of our formulas. And I can replace the top with cos squared x. Notice going down the page. So I have cos squared x over sine squared x, and it's in coses and sines, and it's simplified into one ratio. So I successfully added and subtracted fractions from the question we've been working on. So let's take a look at another example of adding and subtracting fractions. Just going to minimize some of this work, shrink it up top a little bit, and choose another question from the notes. So off to the right, the denominator is sine cos and cos. So all we really have to do is multiply the top and bottom by sine, and then do a bunch of same stuff that we did before, and then use a different identity at the end. So I'm just not going to do that one. Off to the right even is a box that's called separate fractions. And if you ever see an interesting fraction, I'm going to go through that one. Separate fractions is a huge one, and we're going to use it a lot in the future as well. So sine x plus cos x all over sine x. Well, I can separate the denominator, so I can be sine x over sine x plus cos x over sine x, the denominator. Now, looking, sine x over sine x is simply just 1. So I have 1 plus, oh, that's funny. I wrote a different question in the video. It's another similar example in the notes. So look at that one separately, but I'm going to continue. The definition of cos x over sine x is simply cotan x from our formula sheet. Let's circle that one in red. So why would I want to simplify it to that? I don't know. I might want to go back and forth. We have to be able to go very well back and forth between separating fractions and, as we saw in the example above, adding and subtracting fractions with the lowest common denominator. Now, the example below and the example off to the right is exactly the reference to the two different ways that you can work with complex fractions. I'm not going through that theory right now, but I will walk through it on the notes. So again, please have the notes open. I'll walk through it. So 1 over cos minus cos. Notice I don't say x, because it's way easier saying it that way. One more time. The top says 1 over cos minus cos. All over, describing a big over, all over, 1 minus sine over cos. Now as I work down the page, there's always a big over and there's always a bunch of small overs. So I'm going to be working on the top. And I want a lowest common denominator of cos. And cos needs to be multiplied by cos over cos. So I get 1 over cos minus cos squared over cos. And the denominator needs to be over cos, and the number 1 needs to be multiplied by cos over cos. And then I have lowest common denominator, so I add fractions with lowest common denominator. Then I flip and multiply. And then I simplify. I have a cos on the top and a cos on the bottom as an entire factor on the bottom left and the top right. Then I simply have 1 minus cos squared over cos minus sine, and 1 minus cos squared as described in the proofs, in the formulas, as a very useful algebraic formula from the Pythagorean identity that we just did on this same sheet, big red, a manipulation of sine squared plus cos squared. And then we can simplify it to be sine squared over cos minus sine. Notice I didn't say the variables. Now off to the right, it's a little bit simpler. We multiply the top and bottom by LCD, cos x. And as you can see through the steps, that's what I did, and it simplifies way easier. But it's very dangerous because sometimes it's not the lowest common denominator already there for you. Sometimes it's different. You have to do other things before that. So I recommend don't do that method until you get to calculus. And when you get to calculus and you print off my review sheets, you can see the method there and we can review it then. Down below, in the box, inside the box, is the exact same example, doing it all in your head, looking at it and saying, well, I can just times the top and bottom by cos. Try and figure that one out.